All right. Good morning, everyone. So today we're going to be talking about how we're going to work on Hive, so different good practices to work on the cluster environment at UC Davis. So I know I post this on YouTube, and I think there's some people who don't watch from UC Davis, which is fine. I think this is still, at least the screen portion is still relevant, but it is what it is. So before we dive into it, I just kind of want to make sure everyone that's attending right now has access to a Hive account. So you both made your Hive accounts, you're able to log in. All right, beautiful. So there's two ways that we can actually use Hive. So there's what's called the on-demand interface, and I'll dive into what that is in a second. But there's also the command line interface, and there's kind of difference, like there's major differences between them. The most straightforward is just the on-demand way. So it's basically this online interactive type computer. Haha, let me log in really quick. My Duo notification. Okay. So once you click the on-demand.hive.hpc.uc Davis, it will take you to the login page. Once you log in, it will show all of the available applications that you can use. So basically, one of the complications that I think people run into is when you connect to Hive via the command line, people don't really seem to understand in some cases that it's not even your computer that you're connected to. You're essentially remote logging into a computer that exists somewhere physically different from where you are at. So here, this is this gives you the ability to have a computer-like interface, kind of like a remote desktop. So you can initialize an RStudio run. I actually don't know what Blender is. You can launch Jupyter, which I love to use Jupyter. You can launch VS Code. For just simplicity's sake, we're going to launch a Hive desktop just to kind of show you what's going on here. So when you initialize your request for a Hive desktop on demand, it's going to ask you to have any sort of resource allocations. So I have a bunch of random resources that I have access to from when I was a grad student, which is like basically all of them except the public group. But I'll just do Genome Center group for now. And then you're allowed to pick a partition. So this is basically like I think the computer you're connecting to. If you need a GPU and you're doing a bunch of machine learning stuff, then connect to a GPU. Otherwise, I would not recommend that. So mostly just high or low, which is how immediate you need your resources. I'm going to do high just because I want to show something right now. A number of cores needed for your job, just demonstration purposes. So I'm going to put one. Amount of memory, 4 GB is fine. I do not need any GPUs. And I'll only do 1 hour. So at this point, you can either receive an email when the session starts because it will only start once your resources get granted, meaning like there's enough resource availability in the system that you're able to use the amount of cores and RAM that you've requested. And you can also save settings. So let's say that I usually have an instance where I'm like doing a hardcore RNA-seq alignment and I like 64 gigabytes of RAM and I need it for like 7 days or something. Then I can save settings and say like this is how I want to call this session, so it makes it easy in the future. I don't have any saved because I don't really use the on-demand interface. I'm a little old school like that, but that's fine. So then after you request your resources, you will click launch. It says, please be patient as your job sits in the queue. The wait time depends on the number of cores as well as the time requested. And I only requested an hour. I guess we'll kind of let that float in the background and see. It says starting. Your session is currently starting. Okay, there we go. So it's ready. So I requested one node, one core. It says it's running. This is the actual node I'm connected to. So I can click Launch Hive Desktop, and now it should open literally a desktop interface to Hive. So if you're the kind of person who likes clicking around, who likes like the drag and drop kind of stuff, like a typical computer, then this is probably the easier thing to do. It does take time, and I only requested like 4 GB of RAM, so it's basically using all its RAM right now to get itself up and running, which is fine. I haven't played with this in a while, so I actually don't know. Interest. Oh, what the heck? Oh, I think these are Zoom controls. I don't think this is a Hive control. Okay, so we should see. Do you guys see it starting to populate here? Even just like a thumbs up reaction emoji or something. Okay, I'll assume yes. It's okay. We'll return back to this. So yeah, this is the desktop interface. As you can see, it is going to be a little bit slower because some of the RAM that you are using is going to be required just to run this thing. So the other way you can do it, so there's the on-demand interface and then there's the command line interface. Now, I personally prefer the command line interface, first of all, because of what I just said. Like, instead of spending all the resources trying to load an interactive interface, I just use the command line. And the other thing that I think makes this helpful is once you know how to navigate a cluster using the command line, you can do this broadly for anything. Like, my husband works in industry and they have multiple remote computers that they run, and he has to SSH into them, and it's all based on the command line. So it might be easy to have the on-demand interface at Davis, but it's more, I think, broadly applicable if you know how to use the command line interface with the cluster moving forward, just for whatever you do after grad school, postdocing, whatever. So if you want to use the command line interface, then you will log into Hive, and I'm going to split screen here. So you just say SSH your username. My username is vihagani at hive.ipc.ucdavis.edu. And then it will prompt me for my password. I'm a password manager and I'd like to not share that publicly, so I'm going to do that really quick. Okay. And what you're going to notice here is nothing is going to populate. So, like, you can type all you want, it's not going to show up. You just type and then click enter. And then once you click enter, it will log you into Hive. And this will show you a whole interface, like a welcome message. And the thing that they actually added more recently is it shows what default account you're under. It still hasn't changed since I was a grad student. Um, the accounts you have access to, so it shows that I can access the Genome Center groups, Ian Korf's lab, LaSalle lab, and the public group high and low partitions. And to make it fair for users, they basically say like you can't use more than, in this case, like 1,024 GB of RAM a day per user. And then the public group has limits for each job. So if you're using the public group, you can't really submit super high intensity jobs because that if you're doing that kind of level of work, your PI probably has their own compute power. So yeah, this is the Hive interface. The first thing you'll notice if you do LS is there's maybe not as much of this stuff for you guys, but there should be some like maybe a bash RC, a dot profile or something. Depending on what you've run before, there's all sorts of things going on. In this case, there's the on demand because I've run on demand, so it like populates the typical like desktop documents, music, pictures, like that kind of interface. If you want to go to the shared space, it's mounted in Quobyte. So for people who are in like Fink and Helmi labs, you would go to CD, Quobyte, and remember we can tab complete, KD Fink group. Oh, it paused. There we go. And now we can take a look around. So we see archive, backup, lost files due tomorrow, raw data, reference, users, genome. So I'm gonna play around with my folder because I'm familiar with it. So I can go to CD users. And then one thing you'll notice is depending on all these user profiles, there's different people who have created these. So it looks like Ankita created her own folder. It looks like Amber created her own folder. Looks like Julian created Cassiana's folder. I think Kyle created Camille's folder. I actually don't know how that works. But yeah, so there's all these different user profiles, and this is mine. So I'm gonna go to my little directory here and do ls. And I can show you there's all these different projects I'm working on. I have some stuff for Ymira, Cassiana, Claudia, Paula, Victoria, miscellaneous projects I've been up to. So this is kind of how I store my stuff. It's all just on a project by project basis. Now, let's say that I want to run some stuff. Let's say I'm like, you know what? I'm going to go into this X reactivation machine learning folder and I want to run a script. So I have all my setup. I have like this SH script. I have this Py script, like merge parquets. So this script in particular goes and builds like a machine learning matrix Parquet file so that I can train a model, the one that Matangi was talking about at her last lab meeting presentation. But there's a problem here. So if you do htop, there's a limited amount of resources. So we see that each of these things, like this 0 through 63, these are the actual compute nodes. So these are the computers that are up and running just so that users can log in, that they can navigate, nothing crazy. We also see this is the amount of RAM that the system has. It used to be only 64 gigabytes, but I think because more and more users are on here now, they can't maintain 64 without it crashing, so they've increased it to 252. But there's a problem because what if I want to run an alignment that needs 100 gigabytes of RAM? I'm not going to take all those resources from everyone, so I actually need to request resources. So, what I'm going to do here is now show you two different ways you can request resources on Hive. And it's important to note if you're using the on-demand interface, which maybe is still not loaded by now, I guess. Um, what is this? What the heck? I don't know how this works, y'all. That was weird. Anyway, I guess I'll show you. So if we, this is why I don't use on-demand. It's probably more practical if you request more resources. But let's see here. So these are the folders that I had ls when I was in home. So if I do ls home, we see like the desktop music, templates, whatnot, whatnot. So that's all the stuff that's here. I created a symbolic link to ThinkLab. These are all the folders that I was just showing you. So these are my project folders. My like 2026, how am I think, like all those folders. So it's the same interface or it's the same data, it's the same organization, it's just the way that you're looking at it. So if you're doing it on command line, you're just navigating command line style. If you're using on demand, you can actually go ahead and just click and kind of go through things. And it allows you to actually open stuff up. So like if you want to, like that build master Parquet Python file, I think I can open that. Open with, we'll just do Vim for now. You should probably request more than 4 gigabytes of RAM if you're using this. That it was literally just because I wanted a quick access to the session and wanted to show you guys some stuff. But yeah, so it allows you to have like basic like browser access. It allows you to have a terminal. You can navigate the file system. You can make some edits. So this is a lot more drag and drop in style. You can access the file system. So this is Quobyte so that you can navigate to Quobyte and then these are all the people. So I can go to like KD Fink group. which is somewhere here. There we go. So yeah, this is the same stuff we were just looking at. So we can go to users. These are all the people. We can go back to mine. Yeah, we can see everything is kind of set up. So that's, again, one way you can use it. I have personally had some issues using on demand. I think I used to try before and I wanted to be like, oh, I want to open this CSV file and look at it. I want to like mess around with some of my files and edit things. And I found ultimately that it isn't that much functionally different than if I just ran it from the terminal and connected my terminal to my text editor. So, really up to you how you decide to go about this. I'm going to go ahead and log out because I don't need these resources anymore. Okay, I think that's it. Yeah, and then it should show your Hive desktop says completed. So I can delete this because I don't want it, but there you go. So this is the on-demand interface. You can go my interactive sessions, you can look at your jobs, you can start like Jupyter Lab, RStudio, whatever. It depends on what you're trying to run, or you can do tried and true command line. So we're gonna get back to the command line now. So as I mentioned, on demand is really nice because you can request resources when you're creating the session, so you don't really have to think about that too much. If you're logging in with the command line, you do have to be considerate of your resource usage. So there's two things you can do. You can either run a more interactive session using srun, or you can do a batch submission using sbatch. So interactive srun sessions, in my experience, I use for like debugging. So let's say I'm running a script manually. I need to request like 16 gigabytes of data or of memory, for example, so that I can run my script, see the output, run it again, see the output, and kind of go do a little back and forth. So the srun is really helpful for like you expect a lot of back and forth with whatever you're working on. SBatch, or more of the big SLURM submissions, are I have one thing that I'm really running and I just need it to run in the background. Most of the time, I use srun just because I'm doing things kind of interactively. So when you want to initialize an srun session, you just put srun and then you give it a time. So this is 2 hours. If you wanted to do days, it would look something like this. So if I run something for an extended amount of time, I can do like 7 days. I don't need 7 days. So I'm gonna say actually like we just need 30 minutes. So we'll say 30 minutes. So this is the time. And then this will tell it that you're running a bash session, which means you're just consistently keeping your typical command line usage. And then you can also do other things. You can request a certain amount of memory. You can request a certain number of CPUs or cores. You can request a specific account, like public group. So here I can do those things. I can say srun, I want 30 minutes worth of time. I want to have 16 gigabytes of memory. I think G has to be capital. I'm going to request this from Genome Center Group, and I'm going to use the high partition. And then, yeah, so similar to when you launch the on-demand interface, so I guess I'll go back and show those parameters. When you're doing this, the account, the only difference is here you're putting the account here, the partition, you're putting the account in your command line. The number of cores, I think, defaults to 1, so you don't actually need to specify here. The amount of memory that you requested is just mem. We don't really use GPUs in the lab for what we do, so don't even worry about that. But yeah, so this is the big difference. Instead of starting that interactive session with all that, you just kind of put it here and we can click enter and it says the job is queued and waiting for resources. It's been allocated resources and now it's ready to go. So notice that it changed from vHagani at login 2 to at Hive as 11.3-52. So because it is connecting me to a certain amount of resources, it's redirecting me to a computer or a node that has the resources that I'm requesting available. So it's redirected me here. So that's kind of the biggest difference between the two is, yeah, if you're doing on demand, you just request your resources up front. If you're using command line, you log in and then just use srun. So now I can do whatever I want. I can run Python 3 and run some scripts if I wanted to, and that's totally fine because I now have the resources. I have 16 gigabytes of memory for 30 minutes. Now, the one thing that I want to say is every once in a while, I will misjudge a job. I'll say, oh, this only needs to run for 1 day. And usually you want to be nice with your resource requests because I could request instead of 16 gigabytes of RAM, I could have requested 200 gigabytes of RAM for this demonstration. But that's kind of a waste of resources. So you want to generally be kind because other people are using these resources too. So you don't want to request more than you really anticipate needing. Unfortunately, there's not a good way to estimate it other than kind of some trial and error. But I think usually like 16 gigabytes is what a standard laptop runs. So this is roughly anything you could run on your laptop. If you're doing alignments, you probably want something higher than 16, but this should be sufficient. If you're running something, like I said, I've done stuff where I've requested a day and been like, that's fine. Once it hits that time limit, it will say time limit exceeded and then just kill your session. It does not matter if you are in the middle of something. It does not matter if it was 10 seconds away from your job finishing. It's killing your job. Like point blank, it's over. So typically, my MO is to ask for longer time but lower memory because people fight more over memory. So instead of saying I need 64 gigabytes of RAM for 2 hours, I'll be like, how about 32 gigabytes of RAM, but I'll do it for like a day. So it's going to run a little slower, and that's fine, but it has the time to be able to run slower. So now that I'm connected here, I also would like to note, notice we're not actually running anything right now. The nice thing to do if you're running an srun session and you're done with whatever you need is to click or to type exit. So now notice it says exit and it returned me from Hive back to login too. So it's like, sweet. So I don't have any resources that I'm using anymore. That 16 gigabytes of RAM that I requested returns back to the community for the next person to use. So you want to follow along these kind of best practices because it's different from just your personal computer. You're now using a shared resource space where the resources you request and the things that you're doing are now impacting other people. So just be mindful of that. So in addition to running an srun session, you can just run an sbatch script. So this is just something that I'm going to go through as a template because it's literally the same template you will submit every single time. Like every time I want to submit something, I literally just copy and paste this and then edit whatever I need to edit. So you'll change the job name. So if you are submitting an alignment, you can say alignment. If you're like for me, I like to make my job name relative to whatever person's data I'm working on because like sometimes I'm working on Victoria's data, sometimes I'm working on like could be single cell stuff. Like I like to just use their name so I can kind of keep tabs on what's running at any given time. You can put your email because this is not interactive. This is like you click a button, it submits your job, and then you don't know if it ends, if it fails until you check on it yourself, or if it emails you that that has happened. So I usually say mail type all so that I get an email that says your SLURM submission has begun, your SLURM submission has failed, your SLURM submission has completed without error. I just like keeping tabs on that and you can have it send you an email. So that's what mail type is. You can say beginning, end, fail. I just say all. The dash P is the partition. So here it's the low partition. This is just job name. So you just copy and paste whatever you put for your job name and it'll write any errors out to the error file and any output to output. And then You can request the number of computers and the number of cores. In my experience, I just use one and it's been fine. I don't really use much more than that, unless maybe I'm doing an alignment, then I might switch the number of cores to like six or something. Or no, not even that. That's the number of, yeah. No, I just leave these alone. The number of cores per task is what I switch. So yeah, I can switch that to six or eight. This has always confused me. The nodes, computers, cores, and cores per task. That's why I say I just kind of leave both of these at one. I don't touch it and it doesn't yell at me, so it's good enough for me. And then I just switch the cores per task to increase it if I need more. The dash T is time. So as you can see, like in this template, I've literally annotated everything that I need. So I can see like, oh, this is 72 hours. Do I need that? No, yes, let me edit it. Oh, this is 6 GB. Sweet, I can change that accordingly. And then this chdir is the exact directory that you want to run your project in. So if I am running a directory here, I could do pwd and then just copy and paste this into this directory and it will initialize the session in that directory. Because remember, you're essentially submitting a job. It gets assigned to a random computer on the UC Davis campus, but that computer doesn't know where you were. It's just like, all right, you've submitted this job to me. What do I do? So you have to give it some instructions. So you're like, you need to go to this place specifically. You can load Conda, activate whatever environment that you need, and then run your commands. So this is just where your commands go. Functionally, the only things that you need to change if you're submitting something on SBatch is the top portion with all the variables, like the resource requests. If you're activating a Conda environment, then you just put the path to the environment, whatever commands you're running, and that's it. Like this part here does not get touched at all. You just put your commands, your Conda environment, and your variables. That's it. So that's why I say like I just like to use the template whenever I need to submit something. So now let's say that you submitted your job. We'll do an example one here. So let's do cd dot dot mkdir demonstration, cd demonstration, ls. I have nothing in there, that's fine. So then we'll do nano test.sh. So now I can just copy all this stuff in here and change whatever I want. So here for the command, I'm going to do something really, really simple. I'm going to say echo hello. I actually don't need conda, so I'm just going to activate a random environment I have just because I can, I guess. Um, this is the one that I use for my single cell stuff, so I'll say conda activate my single cell RNA-seq.py. And then I get to change this. So I have my job name. We'll put demo job, demo job, demo job. I'll do only 4 cores, and then we only need this for like 10 minutes, if that. And I'll say 4 GB of RAM. And I think we did, ooh, I don't remember the directory. So pwd, this is the directory. So now I can put my directory. Okay, so essentially what I've said is start a demo job with 1 core, low priority. Give me 4 cores for 10 minutes, 4 GB. Go to this directory, activate this conda environment, and literally just print the word hello. That's all I've effectively told it to do. So now I have this script. So this is just a demo. What you can usually do in something like this is like align all your files. But if I want to submit this, now I can run it by saying sbatch. I'm going to rename this actually to, instead of test.sh, test.slurm. So I have test.slurm and we'll do sbatch test.slurm. I forgot to specify the account. Let me do that. I forgot if it's public with a space or not, so I'm just gonna say Genome Center Group. Invalid account partition specified. So this is the partition. This is the account. I am going to put it maybe up here. I don't know if that makes a difference. There we go. Okay, so I just needed to specify the account beforehand, which is fine. That's something honestly you could just ask like AI or look up. That's not too bad. So now that we've submitted it, notice it says submitted batch job. So how do I check it? Well, I can check what the status of my job is by running SQ, but that's really overwhelming, right? We see essentially every single job for everybody who's running anything right now on Hive. That is not helpful in any capacity. I don't need all of these. So what I can do is also run SQ and then do -u because this is username and then say my username. And this will show me what I'm running. Oh, so it shows me that I'm running a bisulfite alignment currently with 125 gigabytes of memory, and it's currently got 4 days left to run, so I'm still doing something. But this is what's running. If I do this again, nothing has showed up. But if I check my emails, here we see name demo job began, and then here name demo job ended. So if we do ls, we see this .err and .out file now. So we can look, say ls demo job.err, or less, not ls, and there's nothing in it. So the .err is standard error. Since there's no error, nothing happens. If we do .out, we said echo hello, so it output hello, and that's what we have here. And then everything else just puts information about the jobs. So it's like this is specifically helpful for if you're running into issues and you're trying to email the Genome Center and be like, hey, I need help with Hive. I have stuff that's going wrong. They're going to be like, can you send me the job information? And then you basically copy and paste this. But this isn't really helpful for you. This is more just an output so you can kind of document what happens with your job. If you're writing files, then your files will appear here. Since we did not write any files, nothing really happens. So that's how you would submit a job to SLURM. And I personally like putting my SQ format a little different. So you can say SQ dash U Vihagani and see only the jobs you're running, but there's some limitations here. You don't see a whole lot of information compared to what you can potentially see. I like having this format here. So I aliased it to SQ me so that I can write SQ me and it would format it the way that I like, where I'm like, this is the account that I'm running it in, this is the node list, this is the nodes I requested, the time limit, the time that it's been running for. Notice here that I'm gonna probably hate myself in 4 hours from now. Um, the fact that it's running, the user, the full name of the job so I could see what's running. So it gives me more information. I usually need that information because I have run things on different accounts, different nodes, different priorities. I like to see the time limit and the time that it's been running in a different format. You can do that. There's all sorts of things you can customize. It's really up to you. Those are all ways that you can just keep track of jobs. If you want to cancel a job, Honestly, I'm just gonna cancel this one because it's going to fail. It's not gonna finish in time. So I can say S cancel and then the job ID. And then now when I write SQ-U Vihagani, it's canceled my job. So my job's no longer running. So that's how you can cancel a job. Now, one last thing. I'm gonna clear my screen here. There is a way that if you're running something interactively, that you're gonna need to step away. So let's say, for example, Victoria actually recently was like, hey, can you download some Novogene data for me? And I'm like, yeah, word, I got you. So I need to download data. But what happens when I download data and it takes 3 days to run and Windows decides it needs to update and it closes my screen and then all my stuff exits and crashes? That's a problem. So there is a way, it's called Screen, that you can kind of resume your sessions and like pick back up where you left off. So you can say screen-ls and it says no sockets found because I killed the only thing I had running. But if I wanted to start a screen, I could say screen dash capital S. Important to note, I do have all of these like cheat sheet actions here. So like to start a screen session, screen dash capital S name, reattach screen dash R. So there's a little cheat sheet. So you don't have to memorize all of these, just to understand the concept that I'm trying to demonstrate. So screen dash S, and we'll say example screen. So now it loads into wherever I want to go to. Remember, I'm still in login 2, so I probably want to request some SRun resources. I have a little like cheat sheet that I consistently keep open for things that I need frequently, so I usually just copy and paste it and edit it accordingly. So we're gonna say like 8 gigabytes of memory for 10 minutes. So it's been allocated resources. And now see, I've switched from login 2 to the whatever node that it assigned me to. So I can now go to Quobyte, Think Lab stuff, and click ls. So let's say now I'm running a Python script here. Well, I'm gonna remove the demonstration because I don't want that. But let's say I'm downloading data here. Now, if I want to step away from it, I can click on my keyboard, Control A and then D, and it says detached from example screen. So now, see, I'm back in login 2. I can do ls, but I'm back in home. I'm not where I was before. But if I do screen dash ls now, it says that I have a screen open in example screen. So what I can do is say I want to reattach to it. So screen dash R for reattach, example screen. And it takes me right back to where I was before. So I have my resources that I requested. Let's say it was still running whatever Python script I was running. It can run in the background. It's downloading data. It's doing MD5 checksums for data. It's uploading data to the NCBI SRA, like whatever it is that you're doing. It's really helpful to use Screen because you can run stuff in the background. So yeah, and then if I want to kill the screen because I don't need it, I'm going to behave and put exit so that I return the resources back. So I've exited, and then I can do Control A and K, and then it'll ask ready to kill this window, and I can just type Y and it will kill the window. So then if I do screen-ls, it says no sockets found. So this is something that's really nice and I think holistically powerful. So going back to kind of an overview of everything we talked about this session, if you're going to be doing any sort of work on Hive, I don't know why it's formatted all weird. There we go. If you're going to be doing any sort of work on Hive, the main things that you need to account for are what resources do you need and how interactive do you need that thing to be. Those are like the two main things to consider. So if you want something that's really interactive, then either the on-demand interface or srun. If you're just running something that you're like, I just need this to run and use some resources, you can submit an sbatch script. If you're doing something that's interactive and you need it to be interactive for an extended period of time, like data download, data upload, then use screen and request resources with srun. So there's a whole lot of combinations, I think, about how to use these different things as a tool. Screen is also not just something specific to Hive. Like I can straight up just open something on my personal computer, so desktop, whatever, and do screen-ls, and it says no sockets found. So you can also use screen on your personal computer if you're running something in the background. It's something that just kind of comes with any command line. But yeah, these are all tools that are kind of best practice tools. And I'm hoping that after we get through a lot of this, I want to try building up to a point that we are all able to run like a demo RNA-seq analysis, like just a bulk RNA-seq analysis. So when you go through that process, you are going to have to use stuff like Screen, srun, SLURM, log into Hive to do that. So these are, even though they're kind of tangential to Python with this being the Python focus group, these are very important resources that relate to running your Python scripts and like how to use compute power and how to run the things that you need to run the right way. So yeah, that's all I have. So I guess I'll pause and see if there are any questions about like sbatch, slurm, srun, screen, or anything. I don't see any questions. So at that point, or in that case, um, the main things I think you can take away from this session, I recommend you to just practice a little with screen, because the whole control A and then D, control A, K, like that's kind of funky. So I would recommend just giving that a little practice, maybe request some resources with srun, submit a test job with slurm, just to try to get the hang of it. And be nice. Don't request too many resources because you're just practicing. All right. Well, since there's no questions, it was nice to see you all. And we are meeting next time at 11 a.m. So on the 19th, we've shifted the meeting to 11, and I will send that in the email. All right. Bye, y'all.
Thank you.